462 is just more on inverse relations and functions. So we're starting with C and D from example 4. So we're just building on what we did in the last one. Notice that there's no graph embedded. We're just going to kind of quickly sketch the graph based on what we know about the type of function to determine whether or not the inverse is a function. And so our steps, remember from last time, were that we want to start with our equation and we want to change our f of x into a y. So I have y equals 2x plus 1. So at this point, what I want to think about is, can I tell whether or not my inverse is a function? Okay, so what I want to think about then is what type of function this is. So 2x plus 1 has x to the first power. This means that it's a linear function. So a linear function is a straight line. 2 is positive, so I can think about it as a positive slope. So if I think about the horizontal line test, then if it passes, so if I cannot draw a line that is horizontal that will cross my graph more than once, then I know that this is a function. So that is true. So this one will pass the horizontal line test because a straight line and any horizontal line that I draw around it will only ever pass a linear function one time. So it's going to pass the horizontal line test. So what that means is that at the very end, my inverse is a function. Okay, so I will be able to change the name to f inverse when I get my answer. Our second step in the process is switching the places of x and y. Remember, that's the idea of creating an inverse function. So instead of y equals 2x plus 1, we're going to solve x equals 2y plus 1 for y. Okay, so we want to isolate the y now. In order to do that, we need to move the 1 over and the 2. So we always undo addition or subtraction first, so we're going to subtract 1. When we subtract 1 from both sides, x minus 1, I cannot combine. And then I canceled this one, so all that we're left with is 2y. Okay, so remember again that we want that y by itself. So since it's being multiplied by 2, we want to divide both sides by 2. Okay, so that means that we're going to end up with just y on this side is equal to. Remember, when we are dividing everything by a number, we want to split those up. So I've got x over 2, and I've got negative 1 over 2. So that means that since it passed the vertical line test, it is a function. So I can change this to f inverse notation, right? So my y becomes f inverse of x because it is a function. If I simplify this, remember x over 2 is a linear function. I write it as 1/2 x. And then I cannot simplify negative 1/2. So the answer to C, for example 4, is f inverse of x equals 1/2 x minus 1/2. For D, we have f of x is equal to 2 minus the cube root of x plus 1. So we're going to start by changing f of x into y. So y equals 2 minus the cube root of x plus 1. So if we think about this type of function, this is a cube root. Remember that a cube root function looks like this. Oops. So if I think about the horizontal line test then, and I were to draw horizontal lines to go through the function, I would never have a horizontal line that crosses that more than once. So this is also going to pass the horizontal line test, which means that it is a function. So when we write our answer, we're able to write it as F inverse. So I have to know visually what each function looks like in order to be able to determine whether or not it will pass the horizontal line test, so that I can tell if its inverse relation is a function. After we our equation, so x is equal to 2 minus the cube root of of y plus 1. So I want to isolate the y. There is a lot happening in this equation. So if I look at that, y is inside a radical adding with 1, and there's a 2, and there's a negative. Okay, so I'm going to have a lot of steps here to solve for y. I'm going to start with outside my radical. So I want to first isolate the radical. Then I can get rid of it to isolate y. So that means that I want to subtract 2 from both sides. So if I subtract 2 from both sides, that gives me on the left x minus 2. I've eliminated that x, but I still have a negative in front of my cube root. So I need the whole cube root by itself. That means I need to get rid of the negative. Remember, I can think about that as though it's being multiplied by -1. So that means that I want to divide by -1. Dividing by -1 is just changing signs. So that means that I'm changing the signs on both of these the same way that all I did here was change the sign to become positive, right? So this becomes a positive cube root of y plus 1. This is going to become a negative x and a positive 2. So then what I want to do is get rid of the cube now. So in order to do that, I need to raise both sides to that same power. So I'm going to cube both sides of my equation. So I had negative x plus 2, I'm going to cube that. I have cube root of y plus 1. That's the reason that I'm cubing this, is so that that becomes just y plus 1. Remember that if this was an even number, I'm sorry, never mind. So then if I cube this, I'm going to leave it not expanded. So I'm going to leave this as negative x plus 2 cubed. Okay, then I have y plus 1. So finally, to get y by itself, I'm going to subtract 1 from both sides. So I cannot combine because this is this big expression, negative x plus 2 to the 3rd power minus 1 is equal to y. Remember that we said that this was a function. So because it passed the horizontal line test, we can write it as f inverse of x instead of y is equal to negative x plus 2 cubed minus 1. Okay, we're going to switch gears from here and look at verifying whether or not something are inverses. So instead of going ahead and solving for an inverse, we're going to look at how that's related to function composition. Okay, so how do I determine if two functions are inverses of each other? So if functions are inverses of each other, f of g of x, so f of g of x is equal to x, and g of f of x is equal to x. Okay, so and. So I use both notations here. So remember that these two things mean the same thing. So in order to determine whether or not two functions are inverses, I have to compose them. If I compose them and I do not get x for either of the compositions, that tells me that no, they are not inverses. So technically I can stop as soon as I plug something in and I don't get x. Okay, so let's look at A. So thinking about what's been happening with inverses, they use the opposite operations. So since f has 2 being multiplied and 5 being added, its inverse should have 2 being divided and 5 being subtracted. So it looks like that's what's happening. So let's make sure that it's in the right order by checking. So we're going to start with f of g of x. Or if you prefer to write it this way, f of g of x. So we're going to start with this one. And we're going to determine if we evaluate that, do we get x? So I'm going to take g and plug it into f. So g is 1/2 x minus 5/2. So I'm going to plug 1/2 x minus 5/2 into the x in f, which is this one. So I'm going to take f 2x plus 5, so 2 times x plus 5. And I'm going to replace the x with 1/2 x minus 5 over 2. Remember, I wasn't multiplying by that x disappears, and the whole function for g gets replaced in there. Okay, so looking at this, I have 2 times an expression that has multiple terms. So that means that I need to distribute. So 2 times 1/2 x is just going to be 1x, right? 2 times 1/2 is 1. 2 times negative 5/2 is just going to be negative 5. If I think about that, the 2's will cancel the same way that the 2 canceled in the half. So, or I can think about it as 2 over 1. So negative 10 over 2 is negative 5. And then I still have this plus 5. So I have to be careful that I don't lose that plus 5 from the original problem. So if I combine like terms, my 5's cancel, and I just have an x left over. Remember that that's what's supposed to happen. I got x for f of g of x. So that means that I have passed the first part of the test. However, I also have to check to see if g of f of x equals x as well. Okay, so I have to check g of f of x, or if you prefer, g of f of x. Meaning, I have to take g and plug the equation for f in. F is 2x plus 5. So I'm going to substitute that 2x plus 5 in for the x in g. So g is the equation 1/2 x minus 5 over 2. Okay, so I left a blank where that x was in g, and I'm going to plug in f, which was 2x plus 5. So I replaced the x of g with the entire equation of f. Okay, so I similarly need to simplify by distributing. So if I distribute 1/2, half of 2x is 1x. Half of 5 is 5/2. I still have a minus 5/2 left over. Notice that if we combine like terms 1x plus 5 over 2 minus 5 over 2 cancels out, is just x. So I got x for g of f of x, which is what I was supposed to do. So what this means is that, yes, f and g are inverses. I have to have both in order to have yes as my answer. Okay, so let's look at another one. So remember that we're doing f of g of x. And we have to also check g of f of x. Okay, so both of them have to be equal to x in order for the functions to be inverses. So if we think about inverses again, inverse operations need to be appear in each of them. So this one has something squared and then adding 5. This one has a square root and subtracting 5. So those operations individually are opposites of one another. So we have to check to make sure that they undo each other, that we end up with just x. So if I'm plugging g into f, I'm taking f, which is x squared plus 5, and I'm replacing its x with g. G is the square root of x minus 5. So I'm going to replace my x here with that expression. So f is x squared plus 5. So instead of x, we've got the square root of x minus 5. Okay, so this one looks complicated. I have a binomial squared. These don't just undo each other because the square root doesn't go all the way across. So I actually have to simplify. So that means that I have the square root of x minus 5 times itself plus 5 still. Okay, so x square root of x minus 5 squared is this expression. I'm going to have to distribute to find this value. The square root of x times the square root of x is x. The square root of x times negative 5 is negative 5 times the square root of x. Notice we have the same thing here. So that's also minus 5 radical x. And then we have negative 5 times negative 5, which is positive 25. And then we still have a plus 5. I'm just going to bring that guy down. Okay, so if I look at this and combine my terms, I end up with x minus 10 radical x, right? I can combine those together, plus 30, because I can combine those together. Notice this is not x. Okay. So what this means is that no, f and g are not inverses. Okay, so as soon as one of them is not x, in order to answer the question, that means that I do not have to check the other one. Just for the sake of practice, we're going to do g of f of x. It's a lot shorter than the last one was. So if I had gotten x here, I would have to do this. Because I didn't get x, I don't have to do this part, but we're going to do it for practice. Okay, so I wouldn't. Need to find this, but we are going to practice. because you'll have these kinds of problems on your quiz where you just have to do that. So practice is good for you at this point. Okay, so what that means is that I'm going to take G and I'm going to plug in my equation of F. My F equation was x squared plus 5. Okay, so I'm taking G, which is the square root minus 5, and I'm plugging in x squared plus 5 where that x was under the square root. Okay, so just like here, right, the square didn't undo the square root the way that it should have. I can't undo here either. So I actually cannot simplify this. So this is the final answer, which is also not x. So that one would have been the easier one to do first because it had a lot less work. So that is how I check to see if functions are inverses of one another. I do composition in both directions. And if I get x, then they are inverses. So these are the triads on page 103.